At the end of the drilling process, the mud is replaced by a completion fluid, most often salt water, and the BOP is removed. The completion process can begin. The objective of this job is to prepare the well already drilled for production. The completion design is made to ensure safely the rate of production of the well given by the reservoir studies during the field's life. During this lesson, we'll see how to connect the reservoir to the well and how to transport the fluid up to the wellhead. Then, we will focus on the performance of a well, including its ability to being eruptive or not. The completion program defines the equipment to be installed in the well at the end of the last drilling phase. More particularly, it has to determine the kind of connection to be used between the reservoir and the well at the well-reservoir interface, and also the equipment installed to lift the fluid produced from the bottom of the well up to the surface. Such choices depend on the kind of fluid produced, the reservoir characteristics, the desired production, the future maintenance of the well, etc. Let's focus on the well-reservoir interface. There are two kinds of connection design: open hole completion or cased hole completion. If an open hole completion is chosen, there is no casing installed at the end of the last drilling phase. The well remains directly in contact with the reservoir. Such a solution is well adapted in the case of well-consolidated reservoirs, when the well produces from one reservoir layer only. It is particularly well adapted for gas wells. On the contrary, a cased hole completion is based on the installation of a liner at the level of the reservoir to be produced. In this case, the reservoir is isolated from the well at the end of the drilling phase. In order to open the connection for the production, a perforation job is necessary. This consists in perforating the casing, the cement, and the rock using a gun suspended on a cable at the reservoir level. This is the most frequently chosen connection. It enables efficient management of the well's stability and is well adapted in the case of a well connected to more than one production zone. Now, let's see how to lift the effluent from the bottom up to the top of the well. Most often, a tubing ensures the connection between the bottom of the well and the wellhead. Such completion is called simple conventional completion. It is the most often chosen and allows the productivity of the well to be optimized by optimizing the internal diameter of the tubing. Moreover, the tubing can be removed and changed if needed. It is also possible to produce directly through the casing. This is what we call tubingless completion. At surface, at the wellhead, a Christmas tree is installed. It includes a choke regulating the production rate of the well and valves useful for well interventions. A safety valve is added to this completion in order to close the well in case of emergency. In the reservoir studies, each well is forecast to produce a certain rate of production, contributing to the field's production plateau. The final well design has to take this objective into account. The well performance engineer aims to study the behavior of each well in production, including the case when the reservoir is depleted, in order to help for the final design of their completions. a well performance study focuses on a well and describes it in terms of pressure. A producing well is connected to the reservoir and produces a part of it, which is called the drainage area. Let's look at the way followed by the fluid from the end of this area up to the wellhead. It starts moving to the bottom of the well due to the drawdown, which is the difference of pressure between the reservoir pressure and the flow's bottom hole pressure. Then, the fluid flows up to the surface through the tubing. It is lifted due to the difference of pressure between the wellhead and the bottom hole. Here is a graph representing the pressure as a function of depth. The slope of the pressure profile in the well depends on the characteristics of the fluid. That means viscosity, density, and the proportion of gas and liquid in the mixture, and on the geometry of the tubing, including its profile and its internal diameter. A well is eruptive if it can produce naturally. It is the case if the reservoir pressure is sufficiently high for the fluid to be able to reach the top of the well without any extra help. Which well is eruptive? Great! You're right! In the first case, we can see that the well isn't eruptive. In fact, the pressure profile in the tubing doesn't reach the wellhead. In the first case, we can see that the well isn't eruptive. In fact, the pressure profile in the tubing doesn't reach the wellhead. On the contrary, in the second case, the pressure profile of the fluid in the well reaches the surface. The well is eruptive. When the well is not eruptive, an artificial lift system is installed with the completion in order to introduce energy from the surface into the well to supplement the natural energy of the reservoir. Two main kinds of artificial lift systems exist: pumps and gas lift. The principle of a pump is to increase the fluid pressure between the pump intake and the discharge. The fluid composition remains the same. On the contrary, implementing a gas lift system consists in injecting gas at the bottom of the tubing. The gas is mixed with the reservoir fluid and decreases its density. The column of fluid in the well is lighter and therefore easier to be lifted up to the wellhead.